Cluster sample means that, for example, let's say like that. Now, you know the corona patients are now spread all over the country. But compared to the other area, that the Minoangoda or the Gampa district is lot of corona patients. Therefore, what they have done is, so when we consider the geographic cluster, then Gampa area is the concentrated corona people are available. Therefore, what they have done, previously the cluster actually they think that the Minoangoda area, and therefore they locked down some nearby, because I'm nearby, I'm also from Gampa. Therefore, they have closed, locked down that the very near the Brandix company, because most people stayed there, and some villages, the people who are the employees are there, the most employees are there in the Kurikatuwa, Maliga, Tenna, likewise that area, and the Luapitiya, Minoangoda, likewise. So they have the Luapitiya, they locked down that area, because in that situation they have taken the cluster. So this cluster means all things get together in a cluster. Therefore, we can divide into the areas, and accordingly we can close or lock down that area, because many people are there. But that is actually not cluster sampling, right? Yeah, no, I want to mention you about the clusters. Clusters is everything getting together, mostly is called as a cluster, right? Now let's see about the cluster sampling again. When the sociology studies, even that we are having the 9 provinces, right? Therefore, when we want to take sample from we want to take sample from 9 provinces, but the situation is we are unable to go or collect sample from all nine provinces. Therefore, what we do is we are getting that the sample from Sabaragamuwa, the northern area, eastern area, and sometimes maybe north. Northern area or northeastern. Likewise, so only the Wayamba, Uva, Sabaragamuwa, එහෙම නැත්නම් central. ඔය හතර විතරක් අපි sampling කරනවා. So that means we are getting the clusters. මේ cluster එක, ඒ cluster එක, ඒ විදිහට, so we can select. So in that situation, we are not going to select that there are 9 provinces, but when we are going to get the sample, අපි තීරණය කරන්නේ නැහැ. Not decided now mama ගන්නේ northern මයි ජෆ්නා පැත්තෙන්මයි ගන්නේ එක තැනකින් එක ඒ cluster එකනොත් මෙහෙම තමයි ගන්න කියලා. So we have decided, right? So the and areas divided into the geographic clusters, and some clusters are selected for inclusion. Some clusters විතරයි ගත්තේ. Have you got the point, Gayatri? Gayatri? Are you all right? ඇහුණාද ඔයගලන්ට? ඇහෙනවද?
Yes, madam.
Right. So that is the clusters. So in that situation, even that, so basically, so when we talk about the corona situation, even so they get the clusters. කියන clusters නේ දැන් මේ හැදිලා තියෙනවා කියන පොකුරු කියන්නේ clusters නේ. හරි? දැන් corona clusters තමයි තැන් වල ඔය පොකුරු හැදිලා තියෙන්නේ. ඒතකොට ඒගොල්ලෝ randomly ඒ cluster වලින් තමයි sampling කරන්නේ. දැන් කොහෙද දැන් ඔය මන්නාරම් පැත්තේ එක පොකුරක් තියෙනවා කියනවා. ඒ වගේ අර කියන්නේ ඒ අපි සිංහලෙන් කියනකොට පොකුරු කියලා කියන්නේ ඒ ක්ලස්ටර් එක තමයි පොකුරු කියන විදිහෙන් අදහස් කරන්නේ. ඒ විදිහට පොකුරු ගොඩාක් තියෙන වලින් අපි selected තැන් වලින් මොකක් හරි sampling කරනවා. So that is the thing. But later on, so however the corona situation, they were unable to control the situation. Then what they have done is they close the western province. ඉස්සෙල්ලා ඒගොල්ලෝ ගම්පා district කරා, ඊට පස්සේ කළුතර district likewise. Finally they have understood that the how they close the question first. But my idea is at the beginning දේගොල්ලෝ අර හොඳටම බ්ලොක් කරා නම් මිනංගඩ ඒරියා එක ගම්පහ ටික කරලා කෙලින්ම හමුදාව දැම්ම නම් අර රටවටේ දානවා වගේ කිසි කෙනෙකුට යන්න දෙන්නේ නැහැ එළියටවත් කොහෙටවත් කියලා එතන බ්ලොක් කරා නම් මම හිතන්නේ මීට වැඩිය ස්ප්‍රෙඩ් කරගන්න එක නවත්තන්න. එතන ඒගොල්ලෝ මම හිතන්නේ ගත්ත ඩිසිෂන් මදි කියලා. මිනිස්සුත් ඉතින් හරි එහෙම නැවතුත් එහෙම 20 සම්මත කරගන්නත් බැරි වෙනවනේ නේද? anyway කොහොම වෙතත් අන්තිමට රටම අමාරු වෙන්න කාගේ හරි වැරදි තීරණ හින්දා එක්කෙනෙක් දෙන්නේ ඩිසිෂන් ගන්න එක ලොකු අය ගන්න නැහැනේ ගොඩාක් එකතු වෙලා අපි තීරණ ගන්න ගියේ නැහැනේ නේද ඒක නිසා finally so everything went to the bad situation. Now brand is open and they are working but the other country is closed, so it's badly affected to the Wayamba, Kelaniya and Colombo and Jaipur, but other universities are functioning. Jaffna අනිත් ඒවා ඔක්කොම function වෙනවානේ. Right, okay. ඒවා exams යනවා ඔක්කොම. Anyway, now let's back to the lecture. Gaisha, I think you are all right with the classes and all the other students. Thank you for the question. Let's come to the preparing sample for analysis. Now I'm going to record this lecture from this point onwards. Good afternoon to you all. So we are going to start today's lecture, preparing samples for analysis. Now, as I mentioned you on the other day, preparing samples for analysis is there may be a liquid sample, there may be a solid sample, there may be a dry sample, there may be a wet sample, there may be a powder, there may be a gas, or likewise there are a lot different type of sample. Whatever the material is, we can say it is a material or the gas or the liquid, so we can say it's a sample. Therefore, and there are a lot of analysis, so you know that for what purpose you are going to analyze the sample. Therefore, we have to prepare the sample for analysis. If not so, in the as it is, we can't. For it can say that in the case of milk sample, if we are going to analyze for the pH of the milk, then we can take the sample as it is because it's a liquid sample. Therefore, we can insert the probe to the milk and check the pH. But if it is a fish sample, let's say it's a fish mussel, we want to check the pH because we want to determine that the spoilage level of the fish. In that case, we are unable to check by or insert the pH probe to the solid sample because that's the solid sample. Therefore, what we have to do is we have to add some water and then blend the sample and prepare the liquid. Then only we can insert the probe and check the pH. Right? So whatever the solution, if we are going to check the pH, we have to prepare a liquid sample because pH is only can determine in the liquid sample by using the pH meter or using the probe. Therefore, so you think that you are going to take the sample of the string hopper mixture, or if so, string hopper mixture is a semi-solid, or the jelly mixture, it is also the semi-solid. Therefore, you are unable to check the pH of that sample. In that case, you have to add some water and blend it, make a homogeneous sample, and then only you can insert that pH probe and check the pH. I think now you can understand what is the meaning of preparing samples for analysis. So if it is now, for example, protein determination, but still I think you have not come to that point, protein determination. So the protein determination, so let's say it's a dry sample or dry fish sample. Then that is a solid sample. Therefore, you can't determine the protein in that dried sample, or it is let's say it's a flour, or it is a dal, or it is a pea, whatever. But if you are going to determine the protein, you need to digest the sample and then determine the nitrogen content of the sample, right? So likewise, so there is a different steps we have to follow before we get the final reading of the final reading or final data about the whatever the thing we are going to determine, right? So after getting that data, even we have to do the calculation. Now think about the principles of food science practical you have done in last semester. So there are a lot of practical you have done. All the practical when you do, for example, I think you have done some titrations, sugar determination you have done. What you have to do is you take the sample and you have to heat it. During the heating you do the titration, and finally you get the reading. That reading is not a sugar content of your sample. Therefore, you have to do the calculation using that reading data, and then you will tell us, okay, this is the sugar percent, glucose percentage of this one is this amount, or likewise you can see. In other cases, when you do the crystal structure determination, so what you have done, so you have to use the microscope. So you have to prepare the crystals, and then under the microscope you have to observe, and using the reference sample. So it's given that this kind of needle pattern is the sugar, this kind of pattern is the maltose, this kind of thing. And therefore, so you know that this after. After checking those things, only by checking the reference sample, you can say that this is this kind of crystal. So this is the sugar, maltose, whatever the thing. So therefore, think about the practical you have done under the first year, under the chemistry lab, or the whatever the situation. So every determinations we have done. So those are the kind of analysis. Now, same thing we are going to learn as a science. That is the only difference thing. And these determinations we are going to use in the wherever the place we are going to work. Maybe sometimes you may a researcher, you are working in the quality control lab, or you are working as a microbiologist, or whatever the place. So the preparing sample for is very important. In the microbiology lab, even you are going to prepare the sample, no? So you have to prepare a sample and prepare the broth, and then you have to prepare the agar plate and put it there, and the spread those Rico, whatever the way you have to do it. And this is the thing. But sample analysis is after analyzing thing, then you can say that okay, the salmonella is there or the E. coli is there, kind of thing. So whatever thing we call is a sample analysis, because in a microbiology even you are not going to use the solid sample, you are going to use the liquid sample. So likewise, I think that explanation is much enough to understand what the preparing sample for analysis. So here we are especially focused on the chemistry analysis, chemical based analysis. In spectrophotometry, color of tested chemical compound may be interfered. Color complex formed by interfering should be removed by masking. For example, now if you are going to use the spectrophotometric method, in that case actually you have to spectrophotometric method, you are determining the color or the absorbance. Especially we determine the absorbance. So Beer-Lambert law is applied there. We check that how the color or the light ray is going through this cell, and then accordingly you determine the deviation of the absorbance of the color. Then we determine how much color absorbed by this compound. Accordingly, that when the concentration is going high in the sample, absorbance level is very high. Therefore, it says 1.5 or 2.5 likewise. So you can get the absorbance limit accordingly. So you check with the standard curve and then find out what is the concentration of the sample, right? So but there is some problems. There are some problems. So what are the problems is, so our sample name is X. We add the reagent Y, X plus Y develop the expected complex. That complex is give a color, maybe blue color, maybe purple color, maybe red color, maybe yellow color, maybe pink color, whatever the color they develop, accordingly that the sample will be absorbed light, right? But X plus Y expected complex, but however X plus is an interfering complex. Therefore, in that situation, if we put the X plus Z plus Y, expected complex is not developed because X plus Z interfered to develop the expected X plus Y complex. Therefore, you are unable to develop the expected color, and followed by you can't measure the absorbance. So what we have to do in that situation? So we have to remove the Z from the sample, or sample, I mean it may be liquid, especially if we are going for a spectrophotometry method, color tested, then it should be a liquid. Therefore, we have to remove the interfering complex making Z from the sample. Therefore, we have to add something and remove the Z from the system in we masking it, and then we add the Y. Now X and Y can join, right? Okay. Then therefore, for that situation, we call again the sample preparation. So ash should be prepared to find mineral composition. If concentrations are low or high, they should be adjusted accordingly. There is another situation, right? Here I mentioned that the interfering complexes, interfering compounds we have to remove from the sample. Then only we can develop the expected complex. Here the other situation, for example, if we are going to determine the mineral composition, in the sample we can't determine. So let's say we are going to determine the phosphorus amount of the sample. In that case, by the normal titration method, we can't determine the phosphorus content. Therefore, what we have to do is, we have to prepare the sample, turn the sample to the ash. Then ash can what vision. Twice before go for a basic step is if consent. So let's say we are going to prepare the sample for the spectrophotometric analysis. If the concentrations are low, the absorbance is very low. Therefore, you are unable to determine the concentration of the sample. In that situation, you have to concentrate the sample. In the vice versa, if the concentration is very high, it is not in the limit of the determination limit, then you have to dilute the sample or adjust it accordingly before you go for a spectrophotometry. Before you go for taking the reading under the spectrophotometry. right? Spectrometer. So there, likewise, so there are different steps are involving before we before we are getting the real final data of the sample of final reading. But final reading is not actually the level, not the percentage of whatever the compound we are going to check. Therefore, sometimes we have to we have to go for a calculations. Sometimes certain other compounds should be added to facilitate detection. For example, here it's given here the total phenolic content determination. So you know that the phenolic compounds are there in any type of the plant material. So when we are going to determine the phenolic compounds or total phenolic content, we have to maintain the base medium. If not, we are not getting the real color, right? So we want to change it to the blue color. Therefore, what we want, we have to add the sodium hydroxide, then only we can go for a blue color. But it's showing like that, the blue color. And so likewise, to get the real color, sometimes addition of the change in the medium is important. Sometimes, so the pH changing is very important. That's why here we put the sodium hydroxide. So sometimes we have to add the EDT or whatever the thing to make a complex. So likewise, so everything is listed in the method. We have to follow it. And however, there is a step. First step is there as a sample preparation. And the sample, now let's go for a perform measurement. Calibration of pH meter and other sensitive instruments are the kind of a perform measurement. So if a pH meter is not calibrated or the other sensitive instruments are not validated, sometimes at the end, whatever the reading you are getting may be having a erroneous results. Therefore, it's a very important calibration of pH meter and other sensitive instruments before we take the readings. In the other case, the blank experiment should be run. For especially in the titrations, even in some situation, you have to do the blank titration because now let's say now you are using some water. The water also having it's a different water we are using. In my lab, the water pH of the water is different with the University of Sri Javadharpur lab water. So likewise, so in such situation, we have to do the blank experiment. So accordingly, so we can remove that the unnecessary involvement of the or the pH changes or the acidic situation or whatever then we can reduce that the blank titration value from the sample value and then go for a calculation. In the calculation, in the semester, you are going to do a lot of experiments, and in that experiment, so you can understand. So we are doing blank experiment all the time. You have to do the blank experiment and then only go for the other calculation. So especially in the titration situation, we have to do the blank experiment. That means only put in the pure water or whatever the dilution. For the dilution, we are using the water. That water, as it is, we are getting the 25 milliliter. And if you are going to get your sample is let's say 10 ml, same 10 ml you have to take. You have to titrate without any your sample, and then divide out of this one to that, and then you can get the real volume spent out of for that means the burette reading. So now unfortunately there is no whiteboard to tell you how to do it, but I think you can understand. If you are having any question, please ask. So there should be a control in every experiment. That is really, really important. When you do the experiments, the control sample should be run. If not, that your results are erroneous. Now see the picture in the bottom left hand side. The control experiments are going on all the time. So we are going to check the fertilizer added soil, whether it is good for food for growing, let's say the sunflower, the plants. So therefore the now normal the control is the normal soil. The good soil is your sample, right? Therefore A, B, the two things are two plants are there in the poor with this poor soil, and good soil is the rich soil. What you have prepared soil, you planted in the CD. Accordingly, you can see that your sample is better compared to whatever the available soil. So likewise, so the all the time the control experiment is should have to run parallel to the your actual experiment. Then only you can say that this thing is really good, right? Compared to the control situation, my situation is better. If someone is going to do another one, sometimes they may use another different control situation. The other important thing is the replication. So you know that I have mentioned in the previous lectures even that the replication is important. So the replication, getting one reading is very imperfect. Therefore, at least you have to take 3 reading and then you have to go for a mean value. That is the very correct thing when you are doing your experiments in the research under the final year research. Definitely you have to think this situation replication is really important. More than 3 readings is needed. So that is why under the principles of food science, sometimes you have taken 2 readings and get the mean value. But under the quality control experiments or the quality control exam, you have to examine every time you have to take the 3 reading. Sometimes if there are no chances for getting 3 readings, but you have to take the other group members reading and then make a 3 reading. So that is very important. Go for a minimum 3 readings. Sometimes 3 reading is not enough. We can take more reading, but at least to take 3 readings, 3 data. So that is why replication is really important, right? So now when we perform the measurement, calibration of this instrument is important. Blank experiment, running the blank experiment is important. Control experiment should have to run parallelly is important, and replication is important. These are the 4 points. Don't forget that wherever the place, whenever the situation, so you have to do these things. Calibration, you have to check whether calibration instruments are calibrated, whether blank experiments are going on, or whether the control is going on, and the applications should have to do at the same time. Then let's think about the weighing scales. So normally when you are doing the analytical experiments, so the analytical when you are doing the analysis, especially we have to take the weight of the sample, because finally we give the data according to these days. Up to now you are getting the milliliter for the mole, or the concentration you are giving the per liter this concentration, mole per liter, or the likewise. But normally when we do other analysis, we have to take the sample, or we have to measure the sample. In measurements, weighing the sample. In that situation, we have to use the weighing scales. There are a lot of type of weighing scales available in the laboratory. Sometimes when you go to the shop, you can see that so the 2 sides are there. Even those things are available in the laboratories. But in such situation, because sometimes there are some labs they are using. So basically now there are the top load imbalances are using. So there are the top load imbalances, laboratory using different top load imbalances. You have to remember those things. Supermarket is having the different top load imbalance, retail shops, home, and every home, I think there are some top loading balance. Scales are there. Therefore, when you prepare the cake or whatever the other things, or some confectionery or the bakery products, you have to weigh the sample, or the flour, sugar, egg, whatever the thing, right? Butter, whatever the thing, right? Therefore, the top loading balances are there. So when you are going to do the analytical, when you are going to do the analysis, sample analysis, if you have to measure the weight, if you have to take the weight of the sample, in that situation, you have to select the correct weighing balance, right? Weighing scale. So the appropriate type of scale must be selected to get the correct measurement. So let's see what is the meaning of that sentence, right? So which scale is suitable to measure 5.634 gram of sodium hydroxide? So you can give your answer unmuting your microphone or in the chat. Which one is suitable for which scale suitable to measure 5.634 gram of sodium hydroxide? Yes, thank you for answering. The B is a answer, because you can see that the A also having given that the scale, they are the weighing things they mentioned, but you got the point 0.0, only one digit or the 1 milligram they can measure, but we want to measure the 6.634. In such situation, we have noted that B is the suitable one. Very correct. Now you can understand, therefore, so all the time when you do the analysis in the laboratory situation, top load imbalances, you have to select the correct one. Very sensitive, the B is very sensitive one, and you have to use it very correctly, and not the A, right? And the A is suitable for what kind of measurement? So let's say now you are going to measure for the flour for a cake, then for cake preparation, cake making. So the A is okay, but B is not suitable, right? So if you are going to measure the 1 kilo of beetroot, B is not suitable. The A is suitable, right? So likewise, so but sometimes A is not suitable. We don't know what is the maximum level can measure by the A. That situation, we have to get the another one, maybe the 10 kilogram or the that scale we have to use top loading balances. You have seen in the shops that there are the sometimes the palam taradi කියලා තියෙන්නේ, the bridge scale. So bridge scales are using for measuring the lorry, the weight of the lorry. The palam taradi. What they have do is the lorries go to the lorry as it is going there, and they measure the lorry, and if they want to measure the content of the lorry, then in the next time they measure the empty lorry weight. They take the empty lorry weight and the good lorry weight with the goods. Finally they can understand, so what is the goods weight. If it's a bigger one, tons and tons, then they measure like that, the palantaradi. And so the maybe paddy and the rice, they measure using the palantaradi, right? And sometimes they have used the gunny bags. You know that the different scales are there. measure right? So a lot of scales are there. You have to select the correct one according to your sample measurement. Now we are going to talk about the buoyancy error. Buoyancy error. So it's very important here. Buoyancy error means the actual mass is mass of an object measured in a vacuum. Now you know we are in an atmospheric condition. So now if you are going to measure 100 gram of sugar in Gampa area, and if you are going to measure the same sample in the Pidrutalagala and the Mudrunta Gihilla, if you go to the top of the Pidrutalagala mountain, so you are getting a different weight. එකම weight එක වෙන්නේ නැහැ, because you know that the pressure is different. එහෙම නැත්නම් හිමාලය කන්ද මුදුන්ට ගියොත් that's or the Alps මුදුන්ට ගියොත්, so if you are going to the Alps mountain, top of the mountain, so the weight is different. So therefore, actual mass is mass of an object measured in the vacuum. But generally, apparent mass is mass of an object measured in an air, right? So the normal air. Air provides the buoyancy effect just like when an object is submerged in water or liquid, but to a significantly lesser degree. So what will happen here? Sorry for disturbing. So what we do here is um, now. So you know why that the balloons are going upside. So because buoyancy force is there, buoyant force is there, and weight is going to the down, but the buoyant force is upper. Therefore, it's going to the up, right? So if the weight is if you are hang a weight to the balloon, then balloon is not going to the up, it's going down, right? So likewise, so that you learn this, the buoyancy errors and buoyancy forces under under the A level physics. So that is it's happening for a small mass. It's depend on the mass. For the bigger masses, it's again the bigger buoyancy phase, but the small masses, it's again the small buoyancy effect. If it is water, you have learned a lot about the water, but in the same case, the buoyancy area is there in the normal environment with the air, right? So air provides the buoyancy effect just like when an object is submerged in water or liquid, but to a significantly lesser degree. Because air density is really small, therefore the buoyancy effect is low in air. But however, that effect is there. Now we can measure this, the buoyancy error or the corrected mass of object. We can measure by using this equation. So the W1 is corrected mass of object. W2 is mass of the standard mass or the measurement. dAI is density of air. D object is density of object, and D weight is density of standard masses used for calibration. Now you have to take the pen and pencil, and you have to and the calculator, then get ready for do the calculation. And write down this equation, because in the next slide you have to use this slide. Have you done it? Take the piece of paper and pen and write down this equation. W1 is corrected mass of object, W2 mass of the standard mass, or the measurement. Measurement means what we have what is the measurement we have taken. So once we measure get the weight, then this is the measurement what we get. The air is density of air, the object is density of the object, and the weight of the density of standard mass. So what we use for the calibration. So let's go to the next slide. And now this is the question. Question 1 is a bottle weighing 7.6500 gram empty weight and 9.97 gram after introduction of an organic solvent, right? Bottle weighing, the empty weight is 7.65 gram. Once you put the inorganic solvent there, the weight is 9.97. Density of the liquid. Now density of the liquid is the whatever the liquid you have added to the bottle. Density of the object also given 8 gram. The density of the air is 0.01. Correct the mass of the sample for the effect of buoyancy error. density of the object is 8. So that is object means what is the, it's a bottle weight, I think 8 gram, no, right? No, sorry, density of the object is 8 gram per cubic meter. Now let me know the answer. You can do the calculation and type it in the chat box. What we have to do is we have to apply these values to the equation given previously. Haven't you got the answer? Was it difficult? What is the answer? Oh, Naveen, are you doing? Naveen and Anuhas? Anusha.
Still doing, madam.
හොඳයි කමන්න හිමින් කරන්න. Madhuru, mosquitoes are coming. There is a problem in the afternoon lectures, evening lectures. When you are doing this, now the empty weight bottle weighing is 7.65 empty weight, and the after introduction of organic solvent, the weight is 9.97. Therefore, the organic solvent weight is 9.97 minus 7.65, right? Don't forget in that point. Then density of the liquid is 0.92. Density of the object is 8. Density of the air also given. Now, using this dAr d object dAr over d object minus dAr over d weight, right? So the calculation that the bottle weight is not coming. chemical balance. No. Yes. Now answer is coming. You can see all the people getting same answer. Someone write 2.3178. Someone is 3.32, 2.32. So likewise, someone use the 4 digits, someone 2 digits. So in that case, so how we are going to give this answer? Make hari uttare 3178. 3178 ne answer එක වෙන්නේ. චූටි වෙලා ගානක වෙනසක් එනවා නේද? 2.318 කියලා එනවා. 2.3211 කියලා එනවා. 3222 එනවා. 3222 322 3178 මොකක් හරි වරද්දලා තියෙනවා. right? උත්තර දෙකක් එන්න බෑ. එක උත්තරයයි එන්න ඕනේ. 3204 කියලාත් එනවනේ. Okay. Let's see. 3178 තමයි වැඩිපුර answer තියෙන්නේ. So, but others මොකක් හරි so someone has written in a wrong way. Right? Here you check again DAR density මේ කොයි එකකවත් මේ දීලා තියෙන value එක ඒකම ලියන්න ඕනේ. right? ඔයගලන්ට value දැන් අපි හිතමු 7.6500 gram නේ තියෙන්නේ. Then so this is asking balance error. Therefore now the bottle weighing even given that the 4 digits. Therefore answer should be in a 4 digits. So me 3176 3178 වැරදෙන්නේ නම් බෑ හැබැයි. ඔයගොල්ලෝ හරියට ඉලක්කම් ගත්තා නම්. Check again, right? Now empty weight is 7.6500 and then liquid weight is 9.9700. So you have to add the 9.00 minus 7.6500. හරියටම අඩු කළා ඒ එන හරියම වැලියු ටික දාන්න round off කරන්නේ නැහැ මෙතනදී. කිසිම තැනකදී round off කරන්න බෑ. density එක 0.92 ඒ වැලියු එකම දාන්න ඕනේ. දැන් object එකක් දීලානේ තියෙන්නේ. මේ ඔක්කොම values ටික දීලා තියෙන්නේ. Are there any problem? DAR density AR D object දීලා තිනවා DAR දීලා තිනවා D weight එක දීලා තිනවා right D weight කියන්නේ density of the standard mass density of the standard of the density of the liquid is giving density of the object is giving density of the air is giving density of the air density of the object එකක් දීලා තියෙනවා density of the liquid එකක් දීලා තියෙනවා right object එකයි liquid එකයි දෙකම දීලා දැන් D weight එකනේ මෙතන එන්නේ D weight කියන්නේ density of the standard mass එකක් දීලා තියෙනවා එතන මාරු කරලා දාලා වගේ මට හිතෙන්නේ ඒකයි උත්තරේ මාරු වෙන්නේ W1 and W2 W1 එක තමයි අපිට ඕන කරන්නේ W2 is the mass of the standard mass so whatever the measurement එකේ දීලා තියෙන ගාන තමයි මේ උගලන්ට මෙතන මේ දෙකෙන් අඩු කරලා එන්නේ right ආන්සර් වර්ධින්න නැහැ um 2.3178 මෙයාට කොහොමද මේ සප්නා 3.3177 ආවේ රුසිරු 2.317 ඊගාවේ ඩිජිට් එකක් ඕනේ. මොකද ඒගොල්ලෝ ඩිජිට් එක 4කට දීලා තියෙනවා නම් ඔයාගේ උත්තරේ හැමතිස්සෙම 4ක්ම වෙන්න ඕනේ, right? මෙතන බලන්න රුවිනිටයි 3.2.3204 ආවි කියලා තුවිනි ආයේ බැක් කැල්කියුලේට් කරලා බලන්න. ඔයාත් මේ දර්ශනත් බලන්න. ශහාරි 318 කොහමද ආවේ රජ්විනි? You do this calculation. මේක හරියට කරන්න මේ සාමාන්‍යයෙන් මම මේ question එකක් දෙනවා MCQ වලට. එතකොට ලියා ගන්න පුළුවන් වෙන්න ඕනේ. Equation එක, so you have to remember the equation. මේ equation එක මතක තියාගන්න ඕනේ, right? Equation එක දෙන්නේ නැහැ. Okay. Right. Now you can understand that so what is the value of the, just a moment, I also want to take my calculator. Now here you can see that the weight we are getting from the liquid weight is getting as a 2.3200 gram, but actual mass weight is, so the answer you are given here is that is actual weight is not the 2.32, actual weight is 2.3178. Actual mass is 2.3178, but because of the buoyancy error, we are getting here the actual weight is 2.32. Right? So now you can understand, because of the buoyancy error is going up, therefore the similar error is coming down. Right? Therefore that error is because of that the buoyancy error, we are getting a higher weight. The actual weight is 3178, because of the buoyancy error of the air is we are getting a bit higher value. Right. I think it's clear to all of you in that point. Let's go to the important aspects of measurement. Important aspects of measurement. Right. So here in the same thing we have mentioned in our today's reading material, mean, median, and rest of the thing, right? Mean, mean sum of all observation divided by the number of observation. So then you can get the mean value of the measurement. So that is why we have to do the replicates, and after that we have to get the mean value. In the same time with the replication, when you are going to do your research in the final year, so there you have to mention it in the standard error and standard deviation. But in here in the laboratory scale experiment, we need not to worry for in the second year level. So you can say that it's a mean value is much important. That mean value only you have to take for your for calculation. Sometimes we are asking you to do the calculation in the 3 times and get the final value and go for a mean value. So that method is it's okay. But if you are getting the mean value and do the one-time calculation, even you can get the same result, right? So because calculation is not changing because of you are getting the mean value or not the raw value. So it's much okay, but however normally we are asking the calculation the 3 times likewise, but the calculation, if you have done the calculation the one time by taking the mean value of the burette reading, it may be all right. නැත්නම් time යනවනේ exam එකක් නේ, ඒක නිසා Then the next one is the median. Median is the middle value of the series. So you have done in the find the mean and median of the data series, right? So the if a number of data, even get the mean value of two middlemost data. So what is the mean value of this data series? Let me know quickly. I think that you have your phones now with you and or the calculators. Let me know what is the mean value of this data series. කන්නඩි කම යන්නත් එක්කලා calculation එකක් කරන්න. What's the value? Mean value? මේ කවුද මේ? It's a Maturi. So you have done it very in a wrong way, right? 16.95 is not there in the mean value or the median. Right, 19.78. That is the mean value. So what is the median value? Very correct. Thank you for answering. Right, good. So what is the median value? When you are typing this even, mama type කරනකොට so dot එක වැරදි තැනක තියලා මටත් වැරදුනා. So therefore when you are using the calculator we have to be very careful. අර මතුරිට වගේ උත්තරේ. So what is the median here? Median is the middle point. You have to put it in the ascending order or descending order and get the median. So what is the median here? $19.7. Right? Find the mean median of the data is 19.7. Good. And let's go to the next slide. Now you can see that the mean value is different, median value is different, and then the other one is the what is the value is so the typing in the same time for a number of time, then we are more mean medium mode, right? So here we are normally that value we are not considering all the time, we are considering the mean value. Good. And then the precision. So let's see what is the precision. So in the reading material even today, it's mentioned that the precision is the closeness of a measurement to the average value. Now precision is the closeness to the average value. Average value means the mean value again. But accuracy is the closeness to the true or actual value. Therefore, the mean value, precision and the accuracy are two different things. Therefore, the precision is not always the correct answer. But basically, we are getting the average value for the closeness is the closeness to the average value. But accuracy is two different situations. Now, I think in the same picture you have seen in your reading material today, if you have gone through it, then you can understand. So, what is the difference? So, right. Give me a few moments. Right. Now you know what is the precision, what is the accuracy. Here in this picture, it says that the low accuracy, low precision. Right. If the true value is there and all the values are gone away, far away from the true value, and all the values are not in the same position. So in that situation, we can say low accuracy and low precision. But all the values are getting closer, but the true value is in somewhere else. Then in that situation we can say low accuracy and low precision. That is there in the right hand side, the top, right? The other one is high accuracy but low precision, because all the values are coming very close to the true value, but the situation is true value, but the situation is it's not it is not in a same point. But in the final picture, you can see in the bottom of the left hand side, you can see high accuracy and high precision. So this one I know that you have learned under the first year, and Dr. Cicero also mentioned the same thing, the precision and accuracy. So I also want to mention here, so now you can understand whatever the thing you have learned in the first year even, now you are going to use here. So the next question time, you are considering the use of new method to measure compound X in your food product. These 6 factors you will consider before adopting this method in your quality assurance laboratory, right? This question has based on the whatever the thing you have learned up to now. So you are considering the use of new method to measure compound X in your food product. Now here as a quality assurance executive or quality assurance manager, you have to sometimes you have to develop the method by your own. If you are working as a researcher in the laboratory, even you have to develop your own method. So in that situation, with the knowledge you have gained up to now, you can answer this question. It's not a big one, but very simple thing. Therefore, take a piece of paper and list out what are the factors. Or if not so, you can add it to the chat box. Whatever the answer you think, you can add here. In the previous should we reduce the empty bottle value from full bottle value? Yes. Jai yes. So there you have to take the correct answer, and then you can calculate it again. So what is the action, or what is the factors you have to consider here? So what are the factors? This is just once you go through the slides, you can't answer, but otherwise for the few answers you can give. The rest of the thing I will fill. But basically from the, so I have mentioned that what are the methods, especially from the beginning, you can consider it and give the answers. Okay, write down some answers. 6 factors you will consider before adopting this method your quality assurance laboratory. What are the factors? Devindi, write one, at least one factor you are thinking. දැන් බයයි වරදී කියලා නේද? It's okay, but write down. What are the factors? Are you confusing with this question? The use of new method to measure compound X in your food product. These 6 factors you will consider before adopting. I have mentioned up to now, I have talked those things, not today, in the previous day even I have talked those things. User-friendly, required amount for a sample, chemical properties of the X, nature of the matter, measure, cost of, yes, Anuhas answers, time that taken to it, uh, how manpower involves, accuracy measurement, size of the compound, environmental factors, adaptability, chemical, yes, good sample type, and required amount of the sample, new procedure, user friendly. For that means compound type, sample type, yes, correct. Then the adaptability. What do you mean the adaptability? Whether we can adapt to that situation, that method to in this lab, physical state, amount of the food sample going to be measured, sample preparation, whether we can prepare the sample in this laboratory, type of food, cost of the test, yes, very correct, Namanithan, yes. Yes, whether the experiment can be repeated, Malinda, time-consuming method or the quick method, Hasini, yes, correct. And available equipment, yes, Devindi, very correct. Available, whether equipments are available, whether before we are going to apply this method, අපිට තියෙනවා the equipment නේද? Instrument and tools, everyone, කවුද? 8 නම ලියන්න. නැත්තම් මට කියන්න වෙන්නේ නම්බරේ නිකන් හිරේ වගේ. 188යි 527. Physical status of the compound, accuracy of the new method. Yes. Now now physical status are not much matter actually. Me Ratnayaka and some also mention about the sample type. But rather than sample type, if we are going to apply this method, so the cost of the method and the equipment's availability and the toxicity, that one also the much important. But if it's a toxicity situation, so we have to take the precaution. So now there are some very good, because you have tried actually. That means you are in the lecture. You think again. So you think about how we can do it. That is the important point. ඒක තමයි මට ඕන කරන්නේ. ඔයගොල්ලෝ ක්ලාස් එකේ ඉන්න ඕනේ. ඒක දකින්න ඕනේ. මොන හරි ලියන්න ඕනේ. එතකොට තමයි තේරෙන්නේ මං හරිද වැරදිද අනිත් එක්කලා ලියන එක මට වැඩක් නැහැ. මම මේ ප්‍රශ්නෙට උත්තරේ විදියට what I am thinking. So that is most important, right? Very good, all the people. Thank you very much for answering. Let's go to the next slide. So yes. Now here the answer is selectivity. The selectivity is you have to select that that titration method selectivity is different. Then whatever the method you are going to use is match with the compound. Method එක match compound එකත් එක්කලා match වෙන්න ඕනේ. එහෙම නැත්නම් so you can't use it, right? And the other one is the precision and accuracy required. So that is very important because sometimes if you are going to use the precision accuracy I mentioned, right? Precision, especially the whether we are going to measure its the actual value is there. That according to if you are going to use the titrometric method, then the accuracy is precision is low. Then if you are going to use the HPLC method, so the accuracy is high. Precision is high. So all the data come into together. And accuracy required also depend on the whatever the method you are going to use. Therefore, the second one is the precision and accuracy. Accuracy of the new method. Yes, Dilchan, you type it, accuracy of the new method, right? Accuracy of the new method means whatever the method you are going to use, whether that method is accurate or give the accurate results. Then the sample type also mentioned, no? You are mentioned the sample type. So whether it is the liquid, solid, or the toxic, or whatever, sample type also important. Thank you very much. So you have to think in that way. Then the sample size also important. I mentioned you the required amount for a sample, because if the sample is very precious one, gold කියලා හිතමුකෝ. So the gold නම් analyze කරන්න යන්නේ for ඒකේ තියෙන mercury වලට හරි so the මොකක් හරි නම් so the water gold ගොඩ හම්බෙන්නේ නැහනේ. because it's a sample is really important. So a small amount of sample you will get. So likewise, it's important. Then the skills and knowledge required එක කවුරුත් type කරේ නැහැ. So you all think that we are really experts, we can do anything here. But skills and knowledge එක මම මුලින්ම කිව්වා. Because laborer can't carry out that experiment, so there should be the trained person. So skills and knowledge requires also then. There are a number of methods now. Let's say high performance liquid chromatography method is there. We know that it's a very precision accuracy is very high in that if you use that method. So there is a HPLC machine also in your lab. But if you don't know how to use the HPLC machine, then if you don't know the skills and knowledge required, then how you are going to use that machine? So therefore, the skills and knowledge also very important. And also the cost of analysis, and mention some of you, and also you have not mentioned, I think, time take for analysis. Take a cover live in a time taken. That's mentioned. Hasini mentioned time taken, whether it's a time consuming method or the quick method. Because, for example, if the process is going on, then if you want to give the data very quickly, then if you are going for a time consuming method, you can't do it. For example, I mentioned the moisture determination. So therefore, time taken for one analysis is also very important, right? That means altogether, all people, Anu has mentioned many answers, and everyone together. So you have covered all these six factors. Thank you so much. And it seems that you are really touching in this lesson. Those are the things. Therefore, now you can understand you are not a normal person. So quality assurance executive is having if you want to involve or apply the new method, එනවා ඔයගලන්ට කරන්න. එතකොට මේ ඔක්කොම දේවල් ඔයාගේ ඔළුවේ තියෙන්න ඕනේ. So now you are in a second year, therefore sometimes you may think අනේ මම කොහොමද එහෙම කරන්නේ කියලා, but actually you can do it. So you have to do it. You must do it. So our duty is to take you to that professional level. At the end of the day, you are a professional, no? Like me. So right. Then right now you know that very very good. Up to now you are really okay with the lecture. So I'm happy about that. And if you have any question, you can ask. You can ask. Now sampling and sample preparation. Next one. And to control good quality, it is important to monitor different characteristics of a product. So therefore, to control good quality, that means quality control of your product, you have to, it is important to monitor different characteristics of the product, not only one product. Sometimes sensitive characteristics, sometimes microbiology, sometimes different chemical analysis, or sometimes different physical analysis, or likewise physical characteristics, chemical characteristics, sensory characteristics, microbiological characteristics likewise. So we have to control different characteristics in the same time. Therefore, the more practical to select the portion of a whole lot. Therefore, to determine all the characteristics, then so it seems like that that so you have to take microbiology take a sample එකක් ගන්නවා. තව එකකට තව එකක් ගන්නවා. තව සැරයක් ගිහින් තව එකක් ගන්නවා. So not like that. You have to go there and pick a sample at once for all the experiments. Therefore, so you have to more practical to select a portion of a whole lot. So if you are going to check the microbiology lot කියලා වගේ ගන්නවා දකුණු කොනේ තියෙන එකක් අර ගන්නවා plus random sampling කරනවා. So if you are going to do the chemical, you do the cluster sampling. So if you are going to do the other thing, you are doing another sampling, right? So you can do like from the whole lot for all the analysis. But whatever the sample you have taken, you have to subject the analysis for microbiology or the chemical or the physical or the sensorial, whatever you have to use. Obtaining a portion or sample that is a representative of the whole is referred to as sampling. and the total quantity from which the sample is obtained is called the population, right? Obtaining a portion or sample that is a representative of the whole is referred to as sampling, and the total quantity from which the sample is obtained is called the population. Now again it's mentioned what is the sampling and population, and the sample and population, that your question was a subset of sample in the whole population is there. If the population very big, then you get the subset of sample and then go for a sampling. If not so, in most of the time you can get the sample from the representing a whole population. By sampling, only fraction of the population is analyzed, and it saves personal time as well as the expense rather than analyzing total population. So that is why we want to do the sampling, because only fraction of the population is analyzed, because we can't analyze the whole population. So in the case of but they are in other situation, but we are talking about the food analysis. But in the case of let's say the garment industry, they check each and every cloth, right? The garment they produce, so they check everything. So they check everything. So therefore, in some situation, you have to check the whole lot. And in some situation, here the food analysis, we are only checking fraction of the sample, fraction of the population. And let's see like that. Now you want to check the metal contamination. Metal can mean, so there is the nail එකක් නැත්නම් machine එකේ යකඩ කෑල්ලක් ඒ වගේ කෑලිත් food industry එකේදී කැඩලා එන්න පුළුවන්. So because the machine, you are working with the machines thing. එතකොට if you are using the bottles පාවිච්චි කරන සමහර බෝතල් කෑලි එන්න ඊට දන්නේ නැහැ වීදුරු කෑලි. So likewise in that situation, especially in the metal detection, so once the package is going through the line, so the metal detector is fixed there, and the metal detector detecting that whether there is any metal pieces inside the package. ඒක කරන්නේ automated machines they use, and then they check it, right? So in that situation, they check whole population. But here we are in the food analysis, we are not checking for checking whole population. The sample is only an estimate of the true value of the population, but with proper sampling techniques, it can be a very accurate estimate. The sample is only an estimate of the true value, right? So this is because sample is there in a now food processing is going on. The sample is there. Samples are there. We are taking we pick the sample, right? We get the fraction of the population as a sample. But here there is no true values given to us. අපිට දැන් දීලා නැහැ මේකේ value එක true value එක මේක ඔයා මේකම තියනවාද කියලා බලන්න කියලා එහෙම check කරන්න. Sometimes it's there because they are the estimations are there, but so the sample is only an estimate of the true value. මේක true value එකේ estimate එකක් මිස true value එක අපිට ගන්න බෑ, because you have noticed that the bias error, you have noticed that likewise because of some errors sometimes you can't get the true value. So in that situation, it's an estimate of the true value of the population, but with proper sampling techniques, it can be a very accurate estimate. ගොඩක් errors mixed වෙනවා. Instrumental error, personal error, system error. Likewise, you have noticed that in your reading material, the different type of errors are given. Because once that all errors are getting together, so therefore in that situation we can't get the very true value of for our measurement. In that situation, actually we have to reduce the instrumental errors, personal errors, method errors, system errors. So everything we have to reduce, and then we can improve the precision. Precision is getting all the data and all data getting together. ඒක එක තැන ගන්න data ටික එක තැනක තියෙන එක ගොඩක් වෙලාවට අපිට කරන්න පුළුවන් by reducing the errors. ඒක ඔයගොල්ලෝ reading method එකේදී කියවුවා, right? පුළුවන්. නමුත් accuracy එක අපිට ගන්න පුළුවන් අපි හරියටම ඔක්කොම errors ටික අයින් කරගෙන හරියම method එක පාවිච්චි කරොත්, so we can go for a accurate result එක. accurate කිව්වොත් ඒකත් පුංචි change එකක් තියෙනවා. ඇත්තම එකට වැඩිය පොඩි change එකක් වෙයි, but it's okay. It's acceptable. Then, so if the value is a 50, if you are getting the value, it's 100, answer is 100, no, it's very wrong. If the value is 50, if you are getting the value nearby the 55 for all testing, then it may be okay. So the ලොකු error එකක් තියෙනවා. So you have to understand that there is something like different, or the error is there. You have to check back everything, point, then correct it. Then you can go for a next analysis. Right. Now we are going to after that. Now we are going to move to in the different section. Right. That is in the 30 minutes we have most the sampling plan. Right. Most sampling is done for specific purpose. So I mentioned you, most sampling is done for specific purpose. So we know that why we are නිකන් මේ අනින ගමන් sample එකතු කරන් යන්නේ නැහැ නේ. So sometimes in my case even මමත් සමහරකට ඔය හොඳට ගල් එහෙම පොඩි ලස්සන බෝල ගල් තියෙන ගඟකට එහෙම ගියොත් ඕකෙන් ගලක් අරන් එන්න හිතෙනවා. මොකද ලස්සනයි ගල. ස්පෙસિෆික් පර්පස් එකක් නැහැ. නිකන් ගලක් අරන් එනවා මම එතනට ගියා කියන්නේ මේකේ ගලක් කියන්නේ එහෙම sometimes so in the Buddhist when we go to the Sri Mahabodhi පුළුවන් නම් බෝකොලයක් හරි අරන් එනවා. There is no specific purpose, but so we like to collect it, right? සමහරකට so when I visited the German in the 2 years back, so that time so I picked a small stone from the German. මේක German පසේ තිබිච්ච. When I visited Canada, මම කැනඩාවෙන් පුංචි ගලක් කරා. මේක කැනඩා පසේ තිබිච්ච ගලක්. So when I visited ඇමරිකාවෙන් නම් ගාගෙන ආවේ නෑ මම. So likewise, when I visited, so likewise, it's not a special purpose, but so I'm happy to say that G අකුර ගහලා German කියන G අකුර ගහලා ඒක තියලා තියෙනවා. So C අකුර ගහලා කැනඩා කියලා තියෙනවා. So likewise, so my hobby. එහෙම හැමතැනම ගල් කියන්නේ. But so ඒ වගේ, right? There was the sampling එකක් නෙමෙයි, but ඒක sampling is done for a specific purpose. එහෙම නැත්නම් මේ ඉන්න බැරිවට අපි sampling කරන්නේ නැහැ, right? There are some factors affecting the choice of sampling plan. Therefore, now we have to decide the sampling plan. Then to decide the sampling plan, there are special factors. So what are those factors? The purpose of inspection, nature of the product, nature of the test method, and nature of the population being investigated. So these things we have to decide that before we decide the sampling plan. Then you have to understand the sampling plan එක දැන් මෙතන නම් ඉස්සරහට කතා කරන් යන එක, it's from this point onwards what we are going to talk is different. ඒකේ sampling plan එක different because this sampling plan we are decided especially thinking about the purpose of the analysis. Here the sampling plan is decided thinking of the purpose of the analysis. And purposes ගොඩක් තියෙනවා. So in the last lecture I mentioned yesterday the specific purposes, whether you are going to give this data to print on the packaging material, or whether you are going to use this data to export, to send with the certificate with the export sample you are going to export, or whether you are going to get this data to release the sample to the market. Likewise, the purpose of the different purposes are there. Or sometimes if you are going to purchase this raw material to your company, in that case even you have to check the sample. So the population, and likewise, so there is a specific purpose. According to the purpose, so you have to decide, or you have to do the sampling. Therefore, the purpose of the inspection, nature of the product, nature of the test method, and nature of the population being investigated is important. Okay, think about that. Right. Purpose of inspection, right? Then let's go to the next slide. The purpose of inspection. What is the purpose of inspection? Is it to accept or reject the lot? So that is very important. As I mentioned you, when you are going to take the sample to your company, because there's a raw material, so you are going to check the sample before you accept the raw material to your company. So if you are going to take the wrong sample, what will happen? Wrong the raw material. So you have to company have to pay for that, and it's a big loss for the company. So in the case of company, in the other, so the basically, so the food analysis and quality assurance that we are talking about in the related to the industry. Therefore, accept or reject the lot is very important, right? And sometimes they accept or release the lot to the market. So as I mentioned you in the getting the example regarding the Kiel's sausage, in that situation, whether we are releasing the company before they release the lot to the market, they have to check it. If batch is contaminated with the salmonella, they can't release that batch to the market. They have to dispose it. So likewise, is it to accept or reject the lot? Testing milk for adulteration at the receiving point of the dairy company. So the testing milk for adulteration, if the milk is adulterated, they are rejecting. If the milk is spoiled, they are rejecting. Therefore, at the testing milk at the receiving point is accept or reject the lot. Right? The likewise, so in the fish case, even the same. If the fish is spoiled, or if the fish is not in the correct quality, or if the fish is having the high histamine value, very important for the export market, they check the histamine level, or the meat, even the whatever the chicken or the whatever the meat, beef or whatever the thing. So likewise, so before they accept or reject the lot, they have to test. So those are the purpose of inspection. Then we have to check on the accept or reject. Accept another, reject another. Yes, now accept, reject now, the no now reject. So that's all. So accordingly, the method we are going to use is different, right? Is it to measure the average quality, right? So whether random inspection of products after producing is it measure the average quality? Here they, for example, that in the case of that salmonella contamination, even we are going to not measure the all the lot, right? We are going to the randomly we take the sample and check it, right? Therefore, is it to measure the average quality, right? Average quality. එතන හැබැයි මේ salmonella කතා නම් average quality එක නෙමෙයි බලන්නේ. But random inspection of the products after producing is we check the average quality. So let's say now in the biscuit case, in the Munchie, Melbourne, you have seen in the TV that how the production is going on. So this roller or the conveyor belts are going on. Conveyor belts are going through the oven, and that time that the heat is generated in the oven, accordingly, the baking is going on. So randomly we check that whether it's in a real brown color, the texture is okay, or then over the likewise we check the average to check the average quality. And inspection of products after producing. Is it to determine the variability of the product? Right? Test for acidity of fruit juices with reference to the identified deviation. In the case of that fruit juice manufacturing company, so they are getting the puree, and puree කියන්නේ pulp එක, right? Puree, and that puree they are going to dilute with the water, adding the water. After that, say they pack it and send to the market. After the puree is coming from not so in the case of mango, so එක mango ගහින් නෙමෙයිනේ ඔක්කොම puree ටික හදන්නේ. එතකොට එකම mango රහ නෙමෙයි. The other thing is the plucking time, plucking so the area, the mango grown area is ඒවත් එක්කලා puree එකේ quality එක වෙනස් වෙනවා. Especially that the ripening stage එකත් එක්කලා ඔයගොල්ලෝ දැන් අඹ කාලා තියෙනවනේ හැමෝම. ඒතර අඹ ගෙඩියෙන් ගෙඩියට එකම ටේස්ට් එක එන්නේ නැහැ. ඔයගොල්ලන්ගේ ගෙදර වත්තේ අඹ ගෙඩිය කැඩුවත් so the other දැන් අද කන එකේ රහ නෙමෙයි ඔයාලට තව ඊගාව එකේ රහ චුට්ටක් වෙනස් වෙන්න පුළුවන්. සිටි වැඩි වෙන්න පුළුවන් because ripening stage when the ripening stage change, so the definitely taste will be changed. Likewise, so when you are going to do the produce company, so they have to check that the final product quality. In that case, so the deviation can be there. The color can deviate වෙන්න පුළුවන්, the taste can be deviate, and then the aroma can be deviate. So likewise, different deviation can be happen. In that case, actually, what they do is they have some natural additive, natural colors or natural flavors or natural aromas. They are add to the final product and they arrange it or may do the markup, right? And if the acidity of the fruit is high, then they add sugar, and they arrange it. Therefore, it is easy to determine the variability of the product එක actual reference එකෙන් වෙනස් වෙලා නම් ඒ ටික check කරන්නත් බලනවා. ඒතකොට ඒක වෙනස් නම් ඒගොල්ලෝ ටක් ගාලා ඒකට precautions අරගෙන හරි product එක හරි ගස්සලා එළියට දානවා. එහෙම නැත්නම් ඒගොල්ලෝ ඒක තමයි බොහෝ විට කරන්නේ. In that case, so they accept or reject is not going on there. They are just they check actual product quality is given here. pH should be there and acidity should be in that, sugar content is මේක, color එක මේක වෙන්න ඕන. Likewise ඒගොල්ලන්ට තියෙනවා මේ list එකක්. ඒ list එක check කරනවා. they check the list. ඒ check list එක check කරන දැන් color එක check කරන්න හැම බලලා නෙමෙයි කරන්නේ. දැන් හැම බලුවා color එක හරි එහෙම නැහැ. So there is a color determination methods. They have to do it and then check the color එක හරියට එනවද කියන එක. Maybe chrome meat එක හරි මොකක් හරි තියෙනවා. ඒකකොට you have to change it. And acidity check කරන්න titration එකක් යන්න ඕනේ. pH check කරන pH meter they have to use. So accordingly they have to make it. So the other is the solid content එක. So you know how to use the Brix meter, and therefore they're using the Brix meter. Even you can find out what is the solid content. මේ ඔක්කොම ඔයගොල්ලෝ පස්සේ පාවිච්චි වෙනවා, right? For the moment you can understand the value, the name, especially when the preservation lectures are going on and preservation methods are going on. Especially then when I lecturing here, if you can hear the unknown word, please you can ask what is the Brix meter. So write down and then check in the internet what's the Brix meter. So likewise, so in the online teaching and this student centered learning, there are a lot of things to do by yourself rather than myself, right? Okay, therefore is it to determine the variability of the product. Now you can see that purpose of the inspections are different. Why we are going to check this sample, why we are checking the quality of the sample. So therefore we have to determine that. Next point is the nature of product. The nature of product is it homogeneous or heterogeneous sample? The homogeneous opposite word is a heterogeneous. So in such situation, you have to homogenize the sample or blending or the grinding or the making powder. Or likewise, you have to take the homogeneous sample. If not so, you have to mix it. Other one is what is the unit size. So the unit size is also important. So if there is a milk bowser, so you need not worry about the unit size neither, because you have to think about what is the unit size. And the nature of the product. The unit is size. If it is sausages, you know that the sausages units are there. I think the unit size is 10 pieces of the sausages are the 1 unit size. So the 5 pieces of the sausage is a unit size. 20 pieces of the sausage is a unit size. In the case of egg, 10 pieces is the unit size. And 6 is the unit size. Likewise, so what is the unit size? 10 grams, so the 20 gram, 50 gram, 100 gram, 500 gram. Then milk packet, there is a 400 gram, then the 750 gram, 1 kilo. Like what is the unit size? So you have to understand that unit size. How consistently have past populations met specification? That is very important. Now the production is going on. The company company. So if you are working there as a quality assurance executive, so you have to check that the past population. So what kind of results we have got? We received. Therefore, whether this one also met the specification. If the past population is not met the specification, then so you have to think about that. There is some kind of a difference. Some changes happen. You have to think about that. But here, how consistently have past population met specification. So the nature of the product. Again, past population එක specification met කළා නැහැ කියන්නේ nature of the product එකේ මොන හරි changes වෙන්න පුළුවන් කියන එක. එතකොට ඒක ගැන ඔයගොල්ලන් අවධානයක් යොදන්න ඕනේ කියන එක තමයි මේ third point bullet එකෙන් කියන්නේ, right? Fourth bullet is what is the cost of the material being sampled. So මම කිව්වේ gold තියෙනවා නම් අපිට මේ gold කිලෝ එකක් ගන්න බැහැනේ. So likewise, so it's a cost of the material being sampled. So the material එකේ cost එකත් අපි දැන් අපි හිතමු. So if it is a canned fish container, you know the canned fish is it's a costly. Now what canned fish analyze කරන්න ඕන නම් if you are working in the Sri Lanka Standard Institute, ඔයා ගිහලා 100 sample 100 canned fish මට ඕනේ analyze කරන්න කියලා, you can't get it like that. You can ask from the company. Send me the 100 canned fish කියලා මොකද ඔය කඩේට දාන්නේ. So likewise, so the cost you have to think. If you are going to analyze the moisture content of the paddy, again we go to moisture content determine right? So likewise, what is the cost of the material being sampled? So that is important. So if cost is very high, large sample cannot be used for analysis. That is happening in the laboratory scale even when you do your research even. So you can't. Cost is very high, large samples can be used for analysis. Right? In some situation, whether it's a cost is high or not, but the very big number of samples. But however, if the cost is high, very minute sample you will get for analysis. That is the nature of the product. Next point is the nature of the test method. Is the test critical or minor? That is very important. Now I mentioned you in the Kills company. Yes, Kills company, before they release the sausage, each and every batch, they check it for microbiological testing, especially in the case of Salmonella and the E. coli, because it's a critical. If product is contaminated with the Salmonella, definitely they can't release the batch to the market because it's a critical. Right? It's not a minor. So therefore, in that situation, they have to give special emphasis or special attention on these analyses. Is the test? Can you understand critical or minor? In the case of milk bowser situation, in the adulteration, even before you take the sample to your company, it's a critical because you can't get the spoiled milk to your company, right? In the case of whatever the fish, even spoiled fish you can't get, or spoiled meat you can't get, right? So therefore, what is the critical or minor? Then if you are going to get the flour for a biscuit manufacturing to the Munchie or the Melbourne or the Diana or whatever, you can't get the gullo gahapu parana vecha epiti ganna, you can't flour you can't use. Then if you use that kind of thing, definitely your product will be ruined. Product එක එන්නේ නැහැ, quality එක ගන්න බෑ. ඒක නිසා දැන් ඔය කරෝල වේලනවා වගේ it's not a critical or minor in the case of dry fish preparation, right? In the most of the situation, people how they prepare the dry fish is whatever the remaining amount එමෙත කුණු වෙච්ච තැලිච්ච පොඩි වෙච්ච කරෝල ටික තමයි කරවල හදන්න ගන්නේ. කොච්චර කිව්වත් they are not using a good quality fish for preparation of the good quality fish for preparation of the dry fish, right? So the good quality so if you, I don't know whether you have noticed that, but especially aquaculture and fisheries, the students who are going to do the aquaculture and fisheries, they have to think about that. So so you have to select you have to go for a very good quality fish for dry fish preparation. ලංකාවේ කරන්නේ කුණු වෙච්ච ඕන මාළුවෙක් කමන්නේ උල්ලුණු ටිකක් දැම්මා අයි කරගත්තා මසල් එක සෙට් කරගත්තා වේලුවා මේක dry fish කියලා, because our people even they happy to taste that අර spoiled taste එක තමයි කරවල කැමති. So the people like the බොම්බිලි කරවල කියලා කියන්නේ බොම්බිලි කරවල හරි ගඳයි නේ හදද්දි මේ මමත් කාලා නැහැ. හැබැයි මම දන්නවා බොම්බිලි කරවල හදනවාද කියලා because people like dry fish. Because that taste they get some kind of a ලුණු රහත් එක්ක එනකොට they like it, right?